So now I've gone back to the example in the notes, and the reason I've left it until now is because it really has introduced a bit of a complication. Not too bad, but you may have been put off by this if it had been the first example that we'd looked at. So it says find the volume of the solid form by rotating the region between y equals x squared and the line y equals 4, the line y equals 4 up here, about the y-axis. So we're going to go from from 0 to 4 around the y-axis, bounded by y equals x squared. It's actually this nice shape, a nice solid forming here. So although it's suggesting we've got a region, it's not too complicated yet. The region, this is probably the most simple region you would ever get. The actual line y equals 4, which is telling us the boundary of the region, actually gives us the limit for our integral. So like I said, it's not too bad. To get its volume, we want pi times the integral 0 to 4, and it is just going from 0 to 4 of our function squared, but hang on, we've got to get x as our subject, so let's do that. We've got y is equal to x squared, x is equal to the square root of y, but the formula says we've got to square x, so our volume is pi times the integral 0 to 4 of x squared, back here really, x squared is y, dy, volume is equal to pi times, add 1 to the index, divide by the new index from 0 to 4, the volume is pi times 4 squared is 16 on 2, minus, and putting a 0 in, pi times 0 is 0, and so we get our 8 pi units cubed. Okay, it does get more complicated than that. It is possible to create a volume where you're taking the region between two curves and rotating that around, say the x-axis, back to the x-axis here. Now, you can see, hopefully you can see, we've taken the region between this straight line and a parabola, straight line and a parabola, and we're going to rotate that around the x-axis. We're going to rotate this funny looking region around the x-axis. The outside of it will look like something familiar, however, we won't have a solid middle because part of the inside of this solid has been cut away by the parabola shape. Then our solid is not complete on its inside. The formula for calculating the volume of this unusual solid generated by taking the region between two curves and rotating it can be found in a similar fashion using the formula pi times the integral a to b of, and it would be the top function squared minus the bottom function squared. Now, because we're going around the x-axis, we're back to just having our functions expressed in terms of the x variable. So it's with respect to x, or dx. And it says there, given that y2 is greater than the y1. So y2 is the top function and y1 is the bottom function. I'll leave the video at that and do the example in another video. Please make sure you understand what's happening here and why it's top minus the bottom, why it's squared. And I will talk more about why the pi is there, like I said, later.